NASA's saving a lot of money now that it's cancelled some Artemis hardware, but the Space Coast is in dire need of repairs. We get up close and personal with Space Shuttle Endeavour on display in its launch configuration. And Rocket Lab launches another Electron in secret? As always, we've got all of that and much more coming up this week in Spaceflight. Last week, we featured a report from the Government Accountability Office on the International Space Station's retirement and the status of commercial space stations. This week, NASA's Office of Inspector General thought it would be a great time to release two separate assessments, one featuring a report regarding NASA's launch infrastructure and another featuring an early evaluation of cancelled Artemis hardware. Let's start with the report on NASA's launch infrastructure. We already covered this in much more detail over on Breaking Space, so make sure to check that out after you've finished this video, of course. The report studies NASA's launch infrastructure at the Kennedy Space Center in Florida and the Wallops Flight Facility in Virginia, but the majority of the challenges this report studies are at the Kennedy Space Center. While the Florida Space Coast is split between NASA's KSC on Merritt Island and the Cape Canaveral Space Force Station located at, you guessed it, Cape Canaveral, NASA offers services across both spaceports, such as the supply of gaseous nitrogen and gaseous helium, which are used commonly for purging, conditioning, and pressurization. Similarly, the opposite is true. Space Launch Delta 45, which is the main group responsible for managing the Cape Canaveral Space Force Station, also offers a multitude of services to those launch pads located at NASA's KSC, like range safety, support, and more. Most, if not all, of the rockets that are launched from the Space Force side of the Space Coast also have to go through NASA's KSC first to get there. This means NASA's launch infrastructure is not just launch pads and their commodities, but also roads and bridges that are used to get from one place to another. The report does not shy away from talking about just how bad the state of this infrastructure is. A lot of it was built several decades ago, so you've got power lines that are well beyond their expected lifetime, roads that support thousands of trucks and other heavy-duty transports that have had little or no maintenance in years, roads that are too narrow for the newer, bigger and heavier rockets, bridges that are too steep for rocket hardware to go over, and a gas supply that gets overwhelmed when giant rockets like New Glenn or SLS are both undergoing launch or test operations. And these problems are only going to get worse as the launch cadence grows as well. And it's not just launches themselves, but also everything surrounding a launch. Pre-launch testing also needs a lot of this same infrastructure. Additionally, you have other things like launch scrubs, where the rocket is still on the ground and goes through everything just like on launch day, at least until the time of said scrub. So that means you still use this infrastructure. We could probably go a lot more in depth into the challenges, but what are the solutions? Well, NASA has been working on these for a while, and they're still working on trying to solve these issues, but as the saying goes, Rome wasn't built in a day, and it just takes time to repair and upgrade this infrastructure. Repair funding is also scarce, and the budget for it has been dwindling over the last few years, and it gets worse when there are laws and regulations in place limiting the scope of NASA's partnerships with the commercial companies using the infrastructure. There aren't any laws that prohibit you from pressing that subscribe button, however. NASA did get an injection of money to spend on infrastructure as part of the so-called Big Beautiful Bill passed by Congress last year, and in fact, the report recommends NASA to prioritize the use of that funding to address some of the issues regarding the infrastructure. These problems are also being worked around by the companies themselves that use the pads, separate from NASA. For example, SpaceX is building its own power storage at Launch Complex 39A for Starship and has moved away from receiving supplies of nitrogen and helium via NASA's pipeline service, instead building its own commodity storage on site. One extra problem is that while the planned infrastructure repairs and upgrades are meant to be in place for the demand expected in the near future, it's not clear whether there'll be enough for the far future. Think, for example, 10 to 20 years down the road. This too would then create more problems down the line, as launch companies are planning to launch a whole lot more from the world's busiest spaceport. The week's second report from NASA's Office of Inspector General is part of a larger audit examining how NASA manages the developed assets of projects terminated prior to launch or operation. Before that larger audit is released, the Inspector General decided to issue an evaluation of some of the cancelled Artemis hardware. This entails the Exploration Upper Stage, the SLS Universal Stage Adapter, Mobile Launcher 2, and Gateway's Habitation and Logistics Outpost. These are often known as EUS, USA, ML2, and HALO respectively. For every single one of these programs, the problem is the same. They were all over budget and behind schedule, and not just by a little, but by several times their original budget and delivery date. Part of these cost overruns and schedule delays have been, in part, due to design changes as NASA asked contractors to modify their designs and as programs came closer to the phase of construction. For example, the EUS design changed early on, and at some point, its work was deprioritized in favor of work on the SLS core stage ahead of Artemis 1. Another contributor has been challenges found during development and construction. Just last year, engineers discovered that Halo's primary structure had widespread corrosion, an issue that's still under investigation and that delayed delivery of the module until July 2028. According to the Inspector General, the combined cost overruns of these programs to date adds up to $3.1 billion and have been late by up to 7 years. Their assessment is that if these programs had continued to completion, the costs would have ballooned more and they would have been delivered even later. The big question is what is going to happen to this hardware. NASA has stated some of the plans, but not all of the plans. ML2 will be cannibalized for parts that may be needed by its much older sibling, Mobile Launcher 1, currently used for SLS Block 1 launches. It's unclear what the Universal Stage Adapter program and hardware is going to be used for, as there aren't a lot of companies out there that may need this glorified cone, and NASA doesn't have any plans to use it. A similar thing can be said about the EUS as well. At one point, it was suggested that Halo, one of the modules of the now cancelled Gateway station, could be repurposed to support the moon base that NASA is developing. It's still unclear as to how this could happen, whether the whole module would be landed on the moon or components of it, such as support systems and electronics, would be repurposed, but we may get some answers sooner rather than later. Other agencies are also pondering what to do with Gateway hardware, since it was an international program. For example, the European Space Agency was providing 2 modules and a communication system for the station. This week, following the conclusion of an ESA Council session, the agency stated that its intention is to continue design and development of one of the 2 modules and keep the technologies from the other module that had already completed development. The communication system could also be repurposed for a dedicated communications relay system around the moon. Just like with the NASA hardware plans, it's still too early to know exactly what way things will go. Now, speaking of cancelled hardware, at least this specific piece of hardware did get to fly. I'll hand it over to Sawyer with a special on-site report.
After 25 missions in space, Space Shuttle Endeavour's mission continues in the form of education here at the California Science Center near Los Angeles. This orbiter exhibit is amazing. It is the first one that is stacked vertically for launch of the 4 exhibits that is out there. It's the only one like that. Most of what you're about to see is flight hardware, and I mean, there's a reason it's the best orbiter. Come on, let's explore it a little more.
We begin with the grand reveal. Through the fog, a wall lifts to reveal OV-105. This is the only time a full stack has been assembled outside of a NASA or Air Force facility. It's something the museum has wanted to do literally since Space Shuttle Endeavour made its first flight 34 years ago.
And we just sort of said, you know, they're going to retire the space shuttle someday. We should try to get one. And if we do, we should put it in launch position. We didn't really know what we were getting into, or we might not have tried, but it's so good that we did.
Almost all of the hardware that you see on exhibit is flight heritage hardware. The solid rocket boosters, or SRBs, are made up of previously flown booster segments from a mix of different shuttle missions. The orange external tank is ET-94, the sister tank of ET-93. That tank flew on STS-107, which saw the loss of foam from the tank impact the shuttle's leading edge, leading to the loss of crew. 94 was then used to study what happened and make improvements for all future space shuttle flights. After being kept in case the Artemis program wanted it, the California Science Center came and scooped it up.
So we did have to install about 1/3 of the surface area of the foam with new stuff, but it was all modeled after the existing foam and carefully hand carved to match the existing texture.
But is it all spray-on foam insulation or Sophie like the real deal? Not exactly.
And the one thing we did to the tank, which you would never do with a real tank, but we needed to make it presentable, was paint it orange. In real life, as I'm sure you're aware, the foam would just rust outside and turn that orange color. But to kind of stabilize it and make it uniform, we put a lot of orange paint on top of it.
One of the 2 payload bay doors is open so you can see inside. This is similar to what Endeavour looked like on STS-118, including a SpaceHab module and the docking adapter for the ISS. Part of the payload liner is peeled back as well, so you can see the inner workings of this amazing vehicle.
Again, the way that they have it displayed here is really impressive because it's all those little details that made the Space Shuttle program the success that it was. And so you can look at any one part, piece, of component, and there's elaborate stories behind it.
One thing astronaut Danny Oliva said to look for? monkey fur. This part right here near the handle.
And you wanted to stay away from the monkey fur because that material would transfer to your gloves, and next thing you know, everything you touch would have you get that grease all over the place, and so stay away from the monkey fur.
Eventually there will be an observation deck here at the top, where you can go up the gantry elevator and look inside the flight deck, but that wasn't open yet. The whole thing is secured to the ground by 8 pre-stressed studs and hold-down bolts at each. There's one difference though compared to the ones that kept Endeavour vertical until the SRBs ignited on the pad.
In real life, the hold-down studs that connected the boosters to the launch pad were only about 2.5 feet long, I believe. Ours are 10 feet long because we have a giant concrete pad with seismic isolators underneath.
The reason? California earthquakes. Turns out, a vehicle that can withstand shaking on launch can actually withstand the Earth shaking too.
If we can withstand flight loads, we can withstand seismic loads.
This exhibit opens to the public November 13th, but keep in mind, if you come here, even though the museum is free, there is going to be a reserved time slot that you need to come here and see it, because otherwise it is going to be an absolute madhouse. But again, this is a must-see exhibit. Of the 4 exhibits that I've seen, this one is, I think, tied for the top with Atlantis, although then again, it does take a little bit more of the cake because we all know Endeavour's the best orbiter, right? I mean, come on, agree with me in the comments. Endeavour, best orbiter, hands down. For NASAspaceflight.com and NSF, I'm Sawyer Rosenstein.
From a beautiful spacecraft on display, we go to a beautiful display of stars, as there's a new picture of the centre of our galaxy, courtesy of the Euclid Space Telescope, showing 60 million shimmering stars. It's the largest and highest resolution picture ever taken of that part of the sky, but it's more than a record-breaking photo, as scientists will later use it to cross-reference observations from a future space telescope. We'll get into that in a bit, but first let's marvel at the picture and dive into how it was taken. It's not actually just one picture, but 9 stitched together into a mosaic. This is very common in astronomy as it allows a telescope to cover a much larger area in great detail. And it's large. It covers the size of 25 full moons, or about 5 square degrees. Impressively, Euclid took only 26 hours to capture the entire image. This is mostly due to its wide field of view. In terms of sharpness and sensitivity, the telescope's performance in visible light is comparable to Hubble's wide field camera, but Euclid can see an area of the sky 270 times larger all at once. Do that 9 times and you get the image we're looking at today. But it is pretty special that we get to see this image at all. Normally, Euclid is dutifully mapping a third of the sky, staring away from our own galaxy. The telescope's main purpose is to study millions of other galaxies, collecting data which astronomers want to use to find the nature of dark matter and dark energy. Our own galaxy only gets in the way of that, so why did Euclid suddenly train its eye on the densest region of the Milky Way? Well, it's to help a future space telescope with discovering exoplanets. Later this summer, NASA will launch the Nancy Grace Roman Space Telescope, which will focus on several topics, including dark matter and dark energy like Euclid. But it will also search for exoplanets using a method called microlensing, which uses a gravitational effect when stars line up from our point of view. When one star passes in front of another, the light from the star behind bends slightly as it passes through the other star's gravitational field, distorting the image we see. This strange effect follows from Einstein's general relativity and means that light bends around massive objects. It's called gravitational lensing, and we see it all the time throughout the universe. But what if the star in front has a planet? Planets are also massive objects, so they should have a similar effect, albeit much less obvious than a star or a galaxy. Roman will look for these subtle effects and use them to find these planets. But it would be really useful to have some long-term data on the stars Roman will observe, which will allow astronomers to do all kinds of things, from determining a star's mass to finding isolated black holes and rogue planets that don't orbit any stars at all. So Euclid observed the Milky Way center on March 23, 2025, 2 years before Roman is set to begin observing the same area. Euclid's study on its own isn't enough to do all this microlensing science yet. For that, a telescope needs to peer at a star for more than 20 days to spot how an orbiting planet affects the lensing effect. Euclid's 26-hour study isn't going to cut it, but it's still a unique picture that we haven't had before, and it's now available to scientists around the world who can use it for all kinds of studies. Now, we're talking about Roman anyway, so let's quickly check in with how that telescope is doing. This week, the spacecraft arrived at NASA's Kennedy Space Center aboard their Pegasus barge, which shipped the telescope from the agency's Goddard Spaceflight Center in Maryland, where it was constructed. Once in the clean room at Kennedy's Payload Hazardous Servicing Facility, NASA will subject the telescope to some final rounds of inspection and testing. Additionally, technicians will fill up the spacecraft's tanks with hydrazine fuel. Then they will hand it over to SpaceX, who will launch it atop a Falcon Heavy no earlier than August 30th. Once in space, Roman will travel to the Sun-Earth Lagrange Point 2, which is also home to Euclid and the James Webb Space Telescope. It appears to be a great place to put an observatory. Speaking of Webb, this week the telescope provided some new insight on 3I Atlas, the interstellar comet that visited our solar system last year. The object was discovered on July 1st, 2025 by the Asteroid Terrestrial Impact Last Alert System, or ATLAS. It's the third confirmed interstellar object to traverse our solar system, hence the name 3I Atlas. The comet came closest to the Sun on October 29th, and Webb studied it a few months later after it was freshly heated by our home star. The heat converted some of the comet's ice into gas, making it easier for Webb to study the object's composition. Webb found that it's especially rich in deuterium, a variant of hydrogen which has a proton and a neutron instead of just a proton like regular boring hydrogen. 3I Atlas has 30 times more of the stuff than the comets in our own solar system. Additionally, the ratio of its carbon content leans heavily towards the lighter carbon-12, whereas our own comets contain a lot more carbon-13. All this points towards ancient origins for 3I Atlas. The comet likely formed early in our galaxy's history in a very cold system. Heat would have converted the deuterium into regular hydrogen, while carbon-13 levels need generations of stars to increase. The researchers behind this study estimate the comet may be 10 to 12 billion years old and spent most of its early days frozen solid. But luckily it visited our neighborhood just in time for us to notice it and study it with our most powerful telescopes, and soon we'll have even more telescopes ready to do science and teach us even more about our place in the universe. Now we'll take a look at some other stories across space, starting with lunar landers. This week, Blue Origin shared a video of its Blue Moon Mark 1 lander deploying its power tower during a test. The tower extends above the lander's top deck to a total height of 26 meters. According to Blue, the test was performed in an analog lunar environment. Now, they didn't say where they did the test, but it looks like it might be the massive thermal vacuum chamber A at NASA's Johnson Space Center. Blue tested Mark 1 in that chamber earlier this year, and it's also where the Apollo spacecraft were tested. The chamber is truly massive. It's just about tall enough to fit the lander with the power tower fully extended. Almost feel like I should be emphasizing that, like, power tower. But why do they need a tower like that? Well, NASA is aiming to land on the moon's south pole with the Artemis program. Some places near the poles are exposed to sunlight pretty much all the time, unlike other latitudes which experience the 2-week-long lunar nights. But the sun comes in at a very low angle near the pole, so you need a vertical arrangement for your solar arrays to get the best performance out of them. It might be a while before we see the power tower in action though. The first Mark 1 was supposed to launch on New Glenn this year, but as you're probably aware, they might not fly for a while following the recent energetic event at its launch pad. A lander that has a better chance of making it to the moon this year is Intuitive Machines Nova C for the IM-3 mission. It's set to launch no earlier than the last quarter of this year, and it will be the company's third attempt at sticking the landing after both IM-1 and IM-2 ended up tipping over while landing. This week, Intuitive Machines gave the lander a hat, or that's what they called it. They're referring to the lander's top deck. The company will now commence full vehicle integration, after which Nova C will perform a hot fire test. Hopefully it will all go smoothly and find its way to the lunar surface before too long. Upright this time. Asteroid Apophis is on its way to Earth, and Germany's OHB Systems has started construction of the European Space Agency's mission to study it. The Ramses mission will study Apophis as it passes by our planet in April 2029 at a distance of roughly 31,600 kilometers. That's closer than geostationary satellites. The Ramses mission is on a tight schedule as it must be launched in 2028 to arrive at the asteroid in time. To speed up the process, it builds on the design of ESA's Hera spacecraft, which is currently on its way to study the aftermath of NASA's DART mission, which intentionally impacted asteroid Dimorphos to change its orbit around asteroid Didymos. Ramses is taking shape in the clean room, although for now it's not much more than a lightweight carbon fibre tube. All the other spacecraft components will attach to this 40-kilogram structure. It might not be much, but it's a great start towards getting the spacecraft completed, which is now scheduled for early next year. ESA aren't the only ones looking to seize the opportunity to study Apophis as it passes by Earth, though. It really is a unique opportunity as it gives scientists a chance to investigate how the asteroid is affected by the tidal forces resulting from Earth's gravity during its flyby. First, NASA has repurposed its OSIRIS-REx mission into OSIRIS-APEX, which will rendezvous with the asteroid after its Earth visit and study the aftermath. China is also planning a mission, but they want to study Apophis during the flyby like ESA. They're using a completely different strategy though. While Ramses will rendezvous with Apophis and fly along with it, China's mission will stay in Earth orbit and try to get within several kilometers of the asteroid as it whizzes by and observe the asteroid with its instruments. What makes this mission more interesting is the team behind the mission. They're undergrad students from Beijing's Tsinghua University who are working with a budget of only $2.8 million US. That's also how the mission gets its name, Student-Led Threatening Asteroid Reconnaissance of Tsinghua, or START for short. The 200-kilogram small satellite is set to launch on a Juche 3 in early 2028. The next few years will certainly be interesting for those who are interested in asteroids. Those missions are a little ways away though. Here's some that are much closer to the present in your space traffic report from next spaceflight. The week started off with another secretive but record-breaking launch by Rocket Lab's Electron rocket. The mission, called VICTUS HAZE, was a rapid response flight in support of the US Space Force's Space Systems Command. The mission is part of the Tactically Responsive Space Program, which aims to develop rapid space capabilities under which the US military would be able to deploy satellites and other assets into space in a relatively short amount of time. The idea is that in the future they could call up a company and quickly develop and launch a mission into space. The Space Systems Command has already carried out a few of these demonstration missions, with the most recent, VICTUS NOX, being launched in 2023 on Firefly Aerospace's Alpha rocket. In that case, the time between the military giving the order to launch and the actual launch happening was about 27 hours. For VICTUS HAZE, it was a more complicated two-launch scenario. The first launch for this mission actually occurred a few weeks ago, when a Jackal satellite from True Anomaly was launched on the most recent SpaceX Transporter mission. This spacecraft simulated a threatening satellite launched by an enemy country that could be potentially hazardous to US assets in space. Rocket Lab's role was to develop, build and launch an interceptor-like spacecraft and perform rendezvous and proximity operations with True Anomaly's Jackal satellite. The Rocket Lab spacecraft, called Puma, is based on the company's Pioneer spacecraft line, leveraging existing supply chains to quickly develop and build it in time for this mission. The company also used its own Electron rocket, which helped control timelines and operations much better than otherwise. All in all, it allowed Rocket Lab to be able to go from notice to launch to the actual launch in just 16 hours and 42 minutes. The Puma spacecraft was also fully commissioned in just over 37 hours following its launch, beating the deadline of 72 hours that the US Space Force imposed on the company for the test by quite a good margin. Apart from that mission, Rocket Lab launched another Electron this afternoon, carrying out the 10 hour of 10 mission for Synspective, marking the 10th strict satellite launched to low Earth orbit by the Kiwi-founded company. This week, SpaceX launched a pair of Starlink missions, deploying 48 Starlink satellites into low Earth orbit. Additionally, SpaceX also launched the first mission of its new Starfall spacecraft. Starfall, which we've covered in some of our recent Starship update episodes, is one of SpaceX's newest programs aimed at carrying recoverable payloads into space, either for short or long periods of time. This includes on-orbit manufacturing of materials or pharmaceuticals, but it could also include hypersonic testing, point-to-point cargo delivery, and much more. This would be very similar to other projects we've covered on the channel, such as Varda's Winnebago spacecraft, which have already carried out similar missions. There is not a lot of information about what exactly SpaceX carried on this Starfall flight, other than it was a demonstration mission. We only know of at least one payload which was on this flight, which was Starbase Brewing's Microbrew 2 mission. It carried different kinds of yeasts and analysed how they adapted to the space environment, similar to other previous flights from this company. Aside from the launches from SpaceX and Rocket Lab, China launched a Changzheng 7A carrying a classified satellite for communication into geosynchronous transfer orbit. Beyond Earth orbit, ESA and JAXA's BepiColombo spacecraft turned off its solar electric propulsion system for the last time as it prepares to enter orbit around Mercury. Until now, the probe used highly efficient low-thrust ion thrusters thrusters located in its transfer module to perform all of its propulsion maneuvers. But once it arrives at Mercury, these will have too little thrust to quickly capture it into orbit. The probe will therefore separate its transfer module ahead of time, currently scheduled for September 3rd of this year, to leave way for its planetary orbiter to conduct the orbital insertion burn using traditional chemical rocket engines. That orbital insertion burn is currently set to occur on November 21st, so we'll cover those events when they happen. Going into next week, we'll have some orbital maintenance with a spacewalk on the International Space Station. NASA astronauts Chris Williams and Jessica Meir will spend about 6.5 hours outside the station replacing a wrist joint on the Canadarm2 robotic arm, which lives on the US orbital segment. Regarding launches, we have another active week coming up. There are up to 4 Falcon 9 launches on tap for next week, with up to 3 Starlink launches and a customer launch carrying SiriusXM's 11th broadcast satellite. We may also have a debut launch and potentially 2 goodbye launches. The debut launch would be of a South Korean all-solid fueled small satellite launch vehicle that's been under development for a few years. This launch has also been postponed several times with no explanation, so we'll see if it actually ends up launching this time around. One of the potential goodbyes this week would be with the launch of a Pegasus XL rocket from Northrop Grumman, launching a satellite to reboost NASA's Swift Space Observatory. The reason it's potentially the last is that this is the last of the Pegasus XL rockets that has been manufactured so far. Northrop has indicated more could be built if there's demand, but the problem is that Pegasus XL hasn't been very sought after in recent years. Another potential goodbye is going to be the last launch of Amazon LEO satellites on board ULA's Atlas V. This makes it the last launch of Atlas V in its 551 configuration, as the only 6 remaining Atlas rockets are supposed to be dedicated to launches of Boeing's Starliner. Considering the state of that program, it's still up in the air whether those launches will occur or not, so it's perhaps not a full goodbye to Atlas V, but definitely a goodbye to its 551 configuration and a goodbye to a satellite launcher family that first reached orbit in 1958. As always, schedules can be fluid, so we recommend you visit nextspaceflight.com or download the app on your phone so you can keep up to date with the launches and other spaceflight events. I've been Ryan Caton for NSF, thanks for watching, and goodbye. Can you see that? 35.8 degrees Celsius. I would love to be frozen solid like that 3i Atlas right now. It is too hot.